I mentioned in the past that we need to find a function, a mathematical function for the beginning, because magnetism organizes into a wave. That means there's something finer. Particles are all made up of the same stuff, and not a long story short, all these particles are, when you bombard them, they all come out of each other. So now we need a mathematical expression, of a function that shows what it is we're looking for. The functions do not exist. So, but inspired by the study of triangles by ancient peoples and an ancient heritage that I am part of, that we are all part of as humans, you can see it in the beadwork, you can see it in sacred geometry, basket patterns, ancient basket patterns, traditional basket patterns, shapes in shapes. And so in this way, I believe we have come across functions that are similar to what we are looking for. Come, let me show you something. This is the kind of function we're looking for, theoretically. You've got energy levels here, you've got original material, and then it goes like this, and it closes, because there is finite amount of everything. So at certain energy levels, you get Y1, Y2, up to Yn. That's it, with N events. So that's what we're looking for. Does it exist in nature? Let's take this pattern, a square inscribed in a circle, Let's say the square is inscribed in a unit circle. So the circle has a radius of 1, and that is the notation, square inscribed in unit circle, UCI. So that is the square, and these are the sides. This will be root 2. Each side will be square root of 2. And now these are all the major sides you need to know. Square root of 2 divided by 2. And at 30 degrees, this is 0.816. I'm not going to go into the detail of it with you, but the maths, you use a spreadsheet or you will never finish it. Use an Excel spreadsheet. And from here, this line we know is 1. So we have key measurements. And from those key measurements, we can get, that is inscribed square inside unit circle. This is what we get from 0 degrees to 360 degrees. As you can see, that's the angle, that's the length. So that's what we get a square, and that is a function, but it is a function. So is it what we're looking for? Maybe not, but let's subtract, let's say the unit square subtracts the length from the square, so it will be just 1, it's all 1 minus the inscribed square. This is the function you get, and it's nice, what we're looking for, but that means when you translate it, it means all the stuff has been used up, to create matter. So it's good for maths, but not good for what we're looking for. Let's look at a unit square. Each side will be 1 unit. And, when getting to a function, so if you have 45 degrees, this would be 0.707. At 290 degrees, it would be 0.532. You calculate these manually. You use a spreadsheet, because these functions we're inventing these functions. We are discovering them. So you calculate them like they calculated sin originally, like they calculated logarithm originally. You calculate the stuff. So you go 1 degree, it will be this length, up to. Don't do it in your manually. You use a spreadsheet. So, and this is the function we get, and this is the function. Note, it's a square is a square. So there's nothing special, nothing different from this with the other square, with the square inscribed in the unit circle, because it's a square. But what we're looking for, what happens when we look at the relationship between the square and the circle? So we have here it is, here's the unit square, So it's still 0.7070, but now it's 1 unit. So here, like this would be 0.5 units, you know. What we do now is we subtract 1, understand? We subtract 1 minus, so it to be here to be 0.707 to be 1 minus 0.707, and this is what we get. Now this is useful now, because this we can now translate. Okay, this is the angle length 0 to 360, but we can translate this to the original stuff, and after certain energy you get unique events. You know, we can describe them as unique, we can interpret them as unique events, but this is just maths. It's just a mathematical function which we are looking at, but it's not what we wanted. You know, going back to what we wanted, this is what we wanted. So maybe this stuff maybe it's not what we but let's turn that unit circle into a diamond and push an edge. At 0 and 360 degrees, it touches. So it just touches once. So now this would be 1 unit. This would be 0.41 units. This would be 0.71 units. Anyway, let me show you, cut that clear. Here are the main measurements. These would be 45 degrees. This would be 67.5, 67.5, 67.5. So we have a triangle here with 2 angle equals. And, you know, you use a spreadsheet and you calculate at 0 degrees, and you can see it to be getting shorter and shorter. And here it to be 0.7654. This is 13.5 degrees, 22.5, 22.5 again. And this, you know, this would be 0.414, 0. So here we've got, you know, then you use a spreadsheet. You'll be forever doing it if you're going to do it manually, you know. But you get the main ideas, then you get a spreadsheet and it will calculate like this. Use the sine tangent rules, use Pythagoras' theorem, you calculate segment by segment. Don't try and, you know, calculate the whole thing at once. And then you calculate at each degree. So this is 0, 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees. What's the length? You know what I mean? So, and then we get this function. This is the function we get. Length, angle, original. Now let's subtract it from the unit square, from the unit circle minus the unit square, and that is almost what we want. It's at 0, 0, and it's a nice something we were looking for. I mean, you can play around with this. You can all this. I haven't tested them, but I'm just showing you. And with the artificial intelligence here, all these, you can measure all these, find out the relationships. That is a lot of mathematics. It was necessary for us to look for this maths and invent this new maths to deal with the reality that all particles are made up of the same stuff. So it's true, necessity is the mother of invention. So now, that's a lot of work, and thank God, you know, there's now artificial intelligence. Imagine doing, because then you've got to find, out of those patterns, you've got to find out the slopes, you know, integrals, you know, the area. It's lot. It's brand new stuff, you know, which there's lots of number patterns to see the relationships. What kind of new number relationships are there to be discovered? It's a good thing it's coming out now at the time of artificial intelligence, because it's a lot of work, and it will keep people, whenever they're bored, they can never say they run out of stuff to do in mathematics. It's practicality, but at the end there is practicality. This is just the beginning of this maths. You are the first people to hear of this. Well, I've written a draft paper. You are the first people to hear of this maths. And I'm sure it's useful to study number patterns. Well, we have found a way of getting to the kind of function we were desiring. Well, have a nice day.